we start with the unit circle definition of trigonometry. Now this is maybe the conceptually most complicated concept in the whole IB. Okay, the other stuff, maybe the question could be harder, but this thing conceptually is quite complicated. Okay, so bear with me in this lecture. I'm gonna go through all the details. Okay, so hopefully by the end you will really understand what's going on, and hopefully that will help you to remember how to correctly use the unit circle in exam. Now granted, in exam they would not ask you anything about the deep conceptual stuff. It's only at the end there are a handful of results that you should remember, and as long as you have a way to memorize those facts, you'll be fine in exam. Okay, but I hope that this video would help you to actually understand it, and at the end I will also tell you how to memorize stuff that you should memorize. So let's go. Now first let's go to the old definition of trigonometry. Okay, so by old it means the opposite side, adjacent side, and hypotenuse kind of definition. So we have a right angle triangle, and then the side opposite to the angle is called the opposite side. Let's say that's called y, and then the side opposite to the right angle is called the hypotenuse. That's called the r, and then the remaining side, which is next to the angle, is called the adjacent side. Then we know the definition of sine theta is opposite over hypotenuse. Cosine is x adjacent over hypotenuse, and then tangent is opposite over adjacent. Now this is work very well, but this put a restriction on the possible value of theta, of the angle that you can put into sine, cosine, or tangent. Okay, and yes, the restriction is that theta has to be between 0 to 90, because it doesn't make sense to have an angle bigger than 90 in a triangle when you already have another right angle, right? Because the angle sum have to be 180. Now on the other hand, if you have your calculator, if you type in sine 100 degree, is actually perfectly fine. Okay, the calculator would probably tell you that sine 100 is 0.985. Okay, corrected to 3 significant figure. So how is that possible? And the answer is because of this. We have a new definition of trigonometry, usually called the unit circle definition. Okay, so now we'll tell you the definition. To begin with that, first we will assume our right angle triangle now have an hypotenuse of length 1. Okay, so imagine I keep the same angle but diminish the triangle so that the hypotenuse only have length 1. Okay, so it becomes y over 1, so sine theta is just y, and then cosine theta becomes x over 1, so it's just x. And then tangent theta doesn't change though, okay, because it's still just y over x. Okay, now then what I can do is I can put this triangle onto a coordinate plane, onto an xy coordinate plane. So put the right angle triangle with angle theta, and now the hypotenuse, remember, have length 1, so this thing have length 1. The opposite side of the triangle, let's say, is still y, and the adjacent side of the triangle, let's say, is still x. Okay, and then we focus on one thing. We focus on the coordinate of this point, of this vertex point of the triangle. Okay, the question is now what would be the x and y coordinates of this point? Okay, well, the answer is straightforward. The answer is just x and y, because this have length x and this have length y. So the y coordinate has to be y and the x coordinate has to be x. Okay, now here is the new definition. I now defined sine theta to be the y coordinate of this point. Okay, and I defined cosine theta to be the x coordinate of that point. Okay, now there is actually a slightly different way of defining tangent, which I might go into it. But for now, let's say we simply define tangent to be sine over cosine. Now note that it works. Sine theta is y, according to our definition, and cosine theta is x. And by it works, I mean you can see that this agree with our old definition. Okay, so for now we'll take tangent theta to be defined to be sine over cosine. Okay, so far so good. Now this is already the so-called unit circle definition. Okay, now what does this really mean, right? So imagine I ask what is the value of sine 80. Then according to this new definition, this is technically what you should do. You should go to the xy coordinate plane and then find a line with length 1. So there's length 1. And then you rotate this line anti-clockwise by 80 degrees. Okay? So you rotate it anti-clockwise by 80 degrees. Okay? So you can imagine I'm basically forming a right angle triangle where this angle is 80. Okay? But forget triangle now. It's simply rotating the line by 80 degrees. And according to this, okay, we just look at this endpoint, and sine of the angle is the y coordinate of that point. Okay, so for this point, you look at the value of the y coordinate, and whatever that is, that's the value of sine 80. Okay? And I hope it's obvious that it will match with the value of sine 80 according to the old definition. Okay, because you could draw a right angle triangle with an angle of 80 and the value you obtained from there would be the same as this, because again, we basically have a hidden right angle triangle somewhere. Okay, so the two definition agrees. Okay, now so why do we bother with the new definition? The answer is because now we can properly find sine 100. Okay, we do the same thing. We find a line of length 1 and then we rotate that line by 100 degrees. So 100 is bigger than 90, so we'll go to that side. So okay, let's say the right angle is 100, and then sine 100, sine is defined to be the y coordinate. So it's here. So that is the value of sine 100. Okay, so that is properly defined now, and it required no triangle. Okay. Now, but it's more than that. The fact is, if we already know the value of sine 80, which conceptually we kind of do, because conceptually we have done this for years, so we sort of know the value of sine 80. You can imagine that we can actually draw a triangle of 80 degrees to measure the length and then actually do a division to find the value of sine 80. Okay, so anyhow, let's assume we know the value of sine 80. Then under that assumption, we actually know the value of sine 100 as well. Because if you think about it, this angle is 10 degrees, because when you go from the x-axis to the y-axis, you have to rotate 90 degrees. So the difference between that to 80 degrees is 10. But to go from 90 to 100, that angle is also 10. Okay? So this two line is actually symmetric of the y-axis. What that means is these 2 points must have the same y coordinate. But the value of the y coordinate is exactly the value of sine 80 and sine 100. Therefore, they must be the same because simply that these 2 points have the same y coordinate. So the conclusion is sine 100 is actually the same as sine 80. Okay? So the magical thing of this new definition is that in order to find the value of sine 100, we actually don't need to do anything new. We don't need to make any new measurement. Because the value of sine 100 is actually the same as sine 80. And let's say conceptually we know sine 80 from the old triangle kind of definition. So conceptually, nothing is new. Nothing new is being created. Let me write the same thing, but on the other side, you see why it looks nicer this way. So the conclusion is sine 100 is the same as sine 80. Okay, cool. What about cosine then? Okay, so similar. What is cosine 80? Well, the answer is cosine 80 is the x coordinate of this point. Okay, so cosine 80 is like here, this x value. Okay, this is cosine 80. Well, what is cosine 100? Well, it's here because it's the x coordinate of that point, so it's here. Now let's think about it. What can you say about these two values? Okay, about this x coordinate and this x coordinate. Well, as I said, this point and this point are the reflection of each other of the y-axis. So it must be true that these 2 points basically have the same y coordinate, except one is negative, the other is positive. Right, well, in particular, cosine 80 is positive, but cosine 100 is negative. Okay, what that means is cosine 100 is the same as negative cosine 80. Okay. Now it might be the first thing that starts to be confusing, the fact that a trigonometric ratio could be negative. This might be new. Okay, it is. So the idea is cosine 100 will have to be negative, simply because by definition, by this new definition, cosine is the x coordinate of this point. Okay. So when this point go to a place where the x coordinate of that place is negative, then cosine would take a negative value. Okay, and that's exactly true here. When you're on this side, when you're on the left-hand side of y-axis, every point would have a negative x coordinate. Okay, so cosine 100 follow directly from the definition that it has to be negative. Okay, and interestingly, the truth is that the value would equal to cosine 80. Okay, so the conclusion is cosine 100 equal to negative cosine 80. Okay. Now it's okay if you are slightly confused. So we'll keep going. We'll show you more what's going on, and hopefully, slowly you will understand more. So let's say next we want to know what's the value of sine 260. Okay. So let me say what we should do again. We should find a line of length 1, rotate that line by 260 degrees. And then for sine, remember sine is a y coordinate, so we look for the y coordinate of this point. Okay. Okay, what can you say? What's the first thing that you can say? Okay, the first thing you can say is the answer to sine 260 should be negative. Why? Because this point simply have a negative y coordinate. Okay, so sine 260 must be negative. The second thing is the value of this y-intercept, of this y coordinate must be the same as the value of the y-coordinate of 80 degree. Okay, because it is simply a reflection. This is like reflection of both the y-axis and x-axis, so you flip twice. Okay, so they must be the same. So the conclusion is sine 260 must be the same as negative sine 80. Okay, so see if we can accept that. Okay, another way to see that this is true is the fact that this angle is also 10 degree. All right, because if you go from the positive x-axis to the negative y-axis, the angle is 270. So if you go 260, you are 10 degree off, and it should be obvious I choose 260 for a reason. Okay, then we can do the same thing for cosine. Let's not do this color. So cosine 260. So similarly, it is the x-coordinate, and the x-coordinate of this point should be negative. And it should also be obvious that this x-coordinate is the same as the value of the x-coordinate of the 80 point, right? So cosine 260 is the same as negative cosine 80. So far, so good. I hope so far, so good. Okay. If you're confused, feel free to ask question below or rewind and watch the video again. Okay. Now, if you are good with sine and cosine, then let's also do tangent. Okay. So far we haven't been talked about tangent. Okay. Now, according to our definition so far, I defined tangent to be sine over cosine. So tangent 260 is supposed to be sine 260 over cosine 260. Okay? Well, as a matter of fact, you may have seen this before. You may have learned this as an identity. In some sense, you could use this to be the definition of tangent. There is another way of defining tangent, but in that definition, this result is still true. We just then call it an identity. So it's fine. Okay, so tangent 260 is sine 260 over cosine 260, but we just found that sine 260 is negative sine 80. So the top becomes negative sine 80. Well, cosine 260 is also found to be negative cosine 80. Okay? So it's simply true that the two negatives cancel out. So it becomes sine 80 over cosine 80. Well, but then by definition, sine over cosine is tangent. So it's become tangent 80. Okay? Like that. Okay, so the full result for 260 is the fact that sine 260 is negative sine 80, cosine 260 is negative cosine 80, while tangent 260 is tangent 80. Okay? Now what happened is a nice pattern has come out, and this is always true. Okay? You can always relate an angle that is bigger than 90 into an angle that is less than 90. Okay, this. Okay, by relate, we mean all three trigonometric ratio would basically have the same value for these two angles. Okay, other than the fact that sometimes it could be positive, sometimes it could be negative. Okay, and it is always the same angles. So if 260 is related to 80 for sine, then it is also true for cosine and also true for tangent. Another fact is sine would always just equal to sine. It is because by definition sine have to be the y-axis. So you match sine with sine, you match cosine with cosine, and you match tangent with tangent. Okay? So there's actually not much confusion going on. Okay, because sine would always just be sine, cosine would always just be cosine, and tangent would always just be tangent. But so far, it seems that the only thing you need to take care of is how do you know that it is 260 that is related to 80 okay? And the other confusion is the fact that when is it negative and when is it positive, okay? So if you can figure out the answer to these two questions, and also hopefully figure a way to memorize the answer to these two questions rather easily or rather conveniently, then that's it. Then you have learned the topic of unit circle. And that will be the goal of this lecture. So at the end, I will provide you a way that I like. It's not the only way, but I really like my way. So, but if you have your own way, you can totally use that. Okay, but before I tell you that way, let's complete the last one, because as you can see, there is still one more grid that is missing. Well, it's not called grid. That is technically called quadrant. Okay, so yeah, terminology. Each region is called a quadrant. As a matter of fact, this is called quadrant 1, quadrant 2, quadrant 3, quadrant 4. Okay. Now, so to complete this example, let's say I want to find an angle that would also be related to 80 degrees. Okay, so I need to find out, I want to find out sine what, where the angle need to be in quadrant 4, and I want it to still equal to sine 80, it's possibly negative, you know. Okay, the question is, what should this angle be? If you think you got it, then give this problem a try. Answer will be coming 3, 2, 1. Okay, it happens the answer is 280, and the bonus would be knowing that sine 280 is actually negative sine 80. Okay, first thing first, why is it 280? The answer is because we want a line that is also 10 degrees away from the negative y-axis. But if you go from the positive x-axis to the negative y-axis, you need to rotate 270 degrees. So if you rotate 10 more degrees, that's 280. All right? Well, secondly, it is negative simply because in quadrant 4, if you're in quadrant 4, your y coordinate must be negative. So sine 280 is negative sine 80. Okay, then what about cosine? Okay, what is cosine 280? Give this problem a try. Answer will be coming 3, 2, 1. Okay, first of all, if 280 is related to 80, then it will be true for all sine, cosine, and tangent. So it is also 280. It's also 80. The angle is also 80. So the question is just whether this is positive or negative. Well, if you're in quadrant 4, your x-coordinate is positive because you're on the right-hand side. So cosine 280 is positive sine 80. And lastly, tangent. Now, if you believe in what I said, then obviously tangent 280 would still be related to tangent 80 because I said the angles are always the same. Now the problem is, should this be positive or negative? Okay, to figure that out, let's do this process again. So by definition, tangent is sine over cosine. Sine 280 is a negative sine 80 over cosine 280 is cosine 80. So this time we have a negative over a positive, so overall it's still negative. So it becomes negative sine 80 over cosine 80, but sine over cosine is tangent, so that's tangent 80. So at the end, it happens that tangent 280 is negative tangent 80. So now we have gone through all 4 quadrants, and that's technically all you need to know. Except there is still two questions, okay? If I give you some random angle, okay, so for example, I ask you what is sine, I don't know, maybe 240, okay? Now, then from this analysis, we know it would equal to plus or minus of some angle inside the first quadrant. All right, but here's the problem. What is that angle, and how do I know whether it's plus or minus? Okay. Now, if you truly understand what was going on, you can go through, you can basically draw this, and then by reflecting along, you will find the angle in the first quadrant, okay? But to do it systematically, let's actually do it in a more general way, okay? So if you go back to this, you can actually find out all the angles that are related to a particular angle theta, okay? Now remember, all the angles in the other quadrant come from reflecting, okay? So we could do that. Okay, so imagine you reflect this triangle along the y-axis, okay? So you get something like this, okay? Okay, so what's going to happen is, like, since you're reflecting, so if that was theta, then this angle is also theta. But remember, we measure angle from the positive x-axis. So the actual angle that you should be talking about is this one. And if that one is theta, then this angle should be 180 minus that. Okay, so that should be clear. Well, and then we can reflect again. So we reflect this along the x-axis. Then you get something like this, okay? Well, this time this was theta, so now this is theta. But again, angle is measured from positive x-axis. So that's like 180 degree plus the theta. And then lastly, you can reflect again to this. And the theta was here, so now theta is here. If you reflect, but again, angle is measured from positive x-axis. So a full circle is 260 degrees. You take away the gap, which is theta. So the angle there is 360 minus theta. Okay? What that means is, in order to be related to a particular angle of theta, the corresponding angle in quadrant 2 is 180 minus theta. The corresponding angle of quadrant 3 is 180 plus theta. And the corresponding angle in quadrant 4 is 360 minus theta. Okay? So just from that, you can answer the first question. What is this box? Okay? Now, 240. So it should be quite obvious that 240 is in quadrant 3. The reason is, if you go from positive x-axis to here, that's 180 degree. If you go to here, that's 270 degree. Okay, so 240 is in between them, and so the angle in quadrant 3 should be 180 plus theta. So this is 180 plus. What that means is theta is 60, right? Because 180 plus 60 is 240. And what that means is the corresponding angle in quadrant 1 is 60. Okay, so this box is 60. Okay, this 60 is also called the reference angle. Okay, so it's like a reference because sine 240 would basically be the same as sine 60. Okay, except you want to also figure out whether that's plus or minus. Now that's relatively not difficult as long as you memorize that sine is supposed to be the y coordinate, and if you are here, your y coordinate is obviously negative, so it's negative. Okay? And so if you think about it, to decide the sine, to decide whether it's plus or minus, is actually not that hard, okay? let's actually do it. If you go to quadrant 2, let's go to quadrant 2. Okay, and then we can ask here, should psi be positive or negative? Well, again, psi is the y coordinate, and the y coordinate here is obviously positive, right? So in this quadrant, psi is positive. Then cosine is the x coordinate, and the x coordinate here should be negative. So let's actually write that down. So in the second quadrant, psi is positive, cosine is negative. And what about tangent? Remember, tangent is sine over cosine. So if you have a positive over negative, it's negative. Okay? And then quadrant 3, this is quadrant 3. For quadrant 3, the y coordinate are negative, so sine is negative. Cosine is x coordinate, that's also negative, right? Because it's here, okay? So here it's negative, this is positive. And then for tangent, tangent is sine over cosine, so negative over negative, that's positive. And then for the fourth quadrant, this is the fourth quadrant, y coordinate is negative, so sine is negative. Cosine is positive because this is x, this is positive. And tangent is sine over cosine, negative over positive is negative. Okay. And then technically we could also fill in for quadrant 1 just to be complete. But in quadrant 1, everything is positive because the y coordinate is positive in quadrant 1, and x coordinate is also positive in quadrant 1, and tangent is also positive because positive over positive is positive. Okay, that shouldn't be of any surprise because quadrant 1 have to agree with the old definition, remember? And in the past, you probably have never seen sine, cosine, tangent being negative in any cases. Okay. So, so in some sense, you could go through what I just did. Just look at the point and think about whether the x coordinate and the y coordinate are positive or negative or not. Okay, but usually what we do is the following. We try to write down which trigonometric ratio is positive in each quadrant. Okay, and the interesting thing is if you go to the quadrant 2, 3, 4, only one thing at a time is positive. So in quadrant 2, only sine is positive, so we write S. In this, only only tangent is positive, so we write T. And then here, only cosine is positive, so we write C. Now for the first quadrant, all three trigonometric ratios are positive, so usually we write A for all. Okay. And I don't know if you have heard of it before. This is known as the cast diagram. Obviously, it's nothing to do with an actual cast of anything. It's just to memorize this. It's not a very good way because it starts from the quadrant the fourth quadrant, and then go to the first one in this way. But that's what people commonly call this. So I'll also just use this name, okay? So you can also use the cast diagram. Remember, the cast diagram is simply telling you which ratio is positive in each of the region. And so the other two ratio will be negative in that region, okay? And that's basically it, okay? So let's try a few more examples. So for example, maybe you have cosine 120 degree, maybe not 120, 150 degree. So first you should think of which quadrant 150 is in, and then figure out the reference angle, and then also figure out whether it should be positive or negative. Okay, you should try this yourself. Pause the video now. And so becoming 3, 2, 1. Okay, let's draw the cast again. C-A-S-T. I also like to memorize the angle of each quadrant, which are these. So in quadrant 1 is theta. Quadrant 2, the corresponding angle is 180 minus theta. The angle in quadrant 3 is 180 plus theta. Quadrant 4 is 360 minus. Okay, 150. 150 is in quadrant 2. Okay, so we should think 180 minus what gives you 150. So that should be 30. So that would mean the reference angle is 30, and so cosine 150 must be the same as cosine 30. And then we think whether that's positive or negative. So in this quadrant it says S, which means only sine will be positive. That means cosine is negative. Okay, now let's do one more. Let's say it's tangent 250. Okay, pause the video now. Give this problem a try. And so becoming 3, 2, 1. 250 is in this quadrant. And so you think 180 plus what is 250? I think that's 70. So this is tangent 70. The reference angle is 70. And then the third quadrant says T. That means tangent is positive. Okay, and so tangent is positive. That's it. And so building on this, instead of using an actual angle, we can actually come up with a bunch of identity. So some book actually list them all out. I mean, you could think like that, but to memorize them is pretty hard unless you use this cast diagram thing. So the identity of this, so sine 180 minus theta. Okay, it simply means if you sine an angle in quadrant 2, okay, well then we know if you sine an angle, it would still be sine. You would sine the angle, you sine the reference angle, okay? And if your angle is 180 minus theta, you must be in quadrant 2, and your reference angle would then be theta. Much like here, if it's 150, then your reference angle is 30, okay? That's exactly because 150 is 180 minus 30, okay? So in that case, theta is 30. And you are in quadrant 2. Quadrant 2 is S, so sine must be positive, so it's positive. And for cosine, it would also equal to cosine theta, but it is in quadrant 2, so it's negative, so on and so forth. Okay, so I think I will list them all at once, but you should not try to like memorize it straightforward. You should try to use the cast diagram and make sure you understand how to use it to get these results, because otherwise that's probably too much to memorize. Yeah. So this is sine. It's negative. This is the fourth quadrant, so it's only cosine is positive. So only cosine is positive, and tangent would then be negative. Okay. Now, before we end this lecture, I want to say, first of all, again, this is quite difficult. Conceptually, this is very deep, and we've talked a lot. You may have forgot something. You may have moments where you think you totally understand everything, and then suddenly you're lost. So that's fine. Just go watch it again. Go back to where you think you understand, and from that point on, watch again. Then the next time you'll probably be less confused. Okay, but the very last thing I want to mention is the meaning of negative angle. Okay, so we can actually do sine of negative 30. Okay, And from now on, we have always been rotating angle anti-clockwise. All right, so if you remember, if you want to find the value of sine 50, what I said is you find a length 1, and then you rotate it by 50 degree, anti-clockwise. Okay, we have been rotating that direction, and then you look for the y coordinate, blah blah blah. Okay, but what would be the meaning of a negative angle? It simply means you turn clockwise. Okay, you turn clockwise. That's known as negative 30. Now, due to this, it shouldn't be difficult to see that sine negative 30 is the same as sine 330. All right, because if you go this way 30 degree, that's the same as going this way 330 degree. Okay, you end up at the same location. And if you're at the same location, then your x coordinate and y coordinate must be the same. And hence the sine value and cosine value must still be the same. Okay. Now mathematically, we can calculate that as saying that you can add to any angle by 360 degree. Okay, because what that means is you turn negative 30 degree, so you turn 30 clockwise, and then you turn a further 360 degree. Okay, so if you have a full turn, then obviously you would go back to the same location, and hence mathematically it's obvious that negative 30 plus 360 is 330. So it has to be true that sine negative 30 is the same as sine 330. Okay. Now with this idea, we can do something like this. We can say what is sine negative theta. Okay, sine negative theta is like sine negative theta plus 360 because you can always turn a complete round. But this is addition. Okay, for addition you can swap the order. So negative theta plus 260 is the same as 360 minus theta. Okay, but according to this, sine 360 minus theta is just negative sine theta. Okay, make sure you understand why, because 360 minus theta is in the fourth quadrant, and in the fourth quadrant is at C, so only cosine is positive, and so sine is negative. Obviously, similarly, we can do the same for cosine. So we'll obtain cosine being cosine negative theta being cosine negative theta plus 260. Then it is cosine 260 minus theta. Okay, but cosine is positive in the fourth quadrant, so this is cosine theta. Lastly, tangent. Okay, it's the same. You probably can do this yourself. If you want, pause the video now. The conclusion is that tangent negative theta is negative tangent theta. Okay? So what happens is, if you sine a negative angle, it's the same as negative of sine the angle. But for cosine, if you cosine a negative angle, cosine will just ignore the negative. But for tangent, it will also take the negative out. Okay, this could be useful from time to time. And we will stop this lecture here.